solve 6x to the negative 2/3 minus 13x to the negative 1/3 minus 5 equals 0. This equation appears to be quadratic in form, but we need to make a substitution to verify that. So I'm going to try and get rid of this x to the negative 1/3. I'm going to make it look like a quote-unquote x. I'm going to use a different variable though. I'm going to say let u equal x to the negative 1/3. Well then, what happens if I were to square that? What is u square? U square would be x to the negative 1/3 square. And remembering from our rules for exponents, if I raise a power to a power, I multiply exponents, and so that's x to the negative 2/3. So by making the substitution u equals x to the negative 1/3, we find out that I can also then make a substitution for x to the negative 2/3, and I get the equation then 6x, sorry, not x. Instead of x to the negative 2/3, I would have u square minus 13u minus 5 equals 0. So now this is quadratic in u, and we can solve it by factoring. I believe this will factor, and if it didn't factor, we could use the quadratic formula. But it does factor. It factors with a 2u and a 3u, a 5 and a 1. 2u minus 5 and 3u plus 1 equals 0. So then if 2u minus 5 equals 0, that implies that u is equal to 5/2. If 3u plus 1 equals 0, that implies that u is equal to negative 1/3. But we didn't want to solve for u, we wanted to solve for x. So we substitute back. Instead of u, x to the negative 1/3 is equal to 5/2 is equal to negative 1/3. All right, so now remember that that is the same as saying 1 over x to the 1/3 is equal to 5/2. Similarly, 1 over x to the 1/3 is equal to negative 1/3. Let's bring that up here. So if 1 over x to the 1/3 is 5/2, that means that x to the 1/3 is equal to 2/5. And x to the 1/3 is equal to negative 3, using the concept of reciprocals. And so then raising both sides of each equation to the 3rd power, we find that x is equal to 8 over 125, and x is equal to negative 27. And we can check our work on those if we'd like.